Hello, welcome back, and I would like to just show you another example using the LOL diagram for interpreting energy of a system, and just wanted to do another example. So here we go. We're going to start off with an archer who has found himself at the top of a cliff. He has already notched his arrow, and he has pulled the string back. And he also is at the top of a cliff, and he is going to then release that arrow, and it's going to fly in a parabolic path towards the ground below. So it's going to take off and kind of fly off, and it's going to end up landing in the ground, or landing over here in the ground. So the initial state I would like to make when the arrow is pulled all the way back, notched and pulled all the way back, and just at rest right before the release. I would like the final state to be just the moment of impact as the arrow impacts the ground. So the arrow is still in flight. In fact, this is going to be the maximum velocity it has at this point. So we're going to draw an LOL diagram for this situation. And again, from last time, we had issues with the system and what should be in our system. So if I were to draw LOL here, I'm just going to put it in here on this side right here. And so in this case, we're going to have energy kinetic, energy gravitational, energy elastic. And the same goes over here, energy kinetic, energy gravitational, and energy elastic. So what I want to start off with is the system, or the system is going to be just the arrow. So I'll include the arrow, and I'm going to include the bow. And that is going to be it. So when I look back and I say, all right, and we're also going to define this here. This will be a height h above the ground. So the system of the arrow and the bow. All right, so because there's no earth in the system, we're not allowed to have gravitational energy. We have no kinetic at the initial because at this point in time, the arrow has no velocity, and neither does the bow. And the elastic energy, though, is prevalent because we do have stretched the bow material, which is like usually made of wood, and it's been pulled back, and therefore it has no longer in its natural state. So we're going to give it some elastic energy, and it doesn't really matter right now how much I give it, but I'm just going to give it 3 units right here. 1, 2, 3. All right. So then at the end of that, the arrow has acquired some energy here. It is actually moving quite fast. And if you think about it, from here, the arrow is not moving, but at the moment it was launched, it has a high velocity. But think about what's happening as it's going through its parabolic path here. You remember that gravity always acts straight down. So if I draw at this point right here, here's the point of the arrow, the force of gravity is pulling downward. And eventually it's pulling in a direction that will accelerate it and make it go faster. So I'm going to actually end up with a higher amount of kinetic energy than I started with elastic. So this was 3, I'm going to make it 5. So I'm going to give this a solid 5 blocks. So 1, 2, 3, 4, 5. Okay, so I got 5 blocks. So according to the law of conservation of energy, I actually have gained energy. And now how does that happen? Well, it turns out that there's something that was outside the system that caused the energy to go up. And that was, of course, this external force by gravity that caused it to speed up faster than it normally would after the release. So since this was 3 blocks and this is 5, we need to have 2 blocks of energy coming in, and this is work done by the Earth itself. The Earth did work to give the arrow a greater velocity here than it was at the release. Now what I want to do is write an equation that explains all the energies that are going on. So I'm going to start off with my initial state. Remember, this was the initial, this was the final. So I can write the energy elastic at the initial state. And this is going to be adding energy in, so I'm going to add to that the work done by the Earth. That should give me the energy kinetic in the final state. And so this right here represents their energy equation that will help us go further, and later on we'll discuss each one of these terms here will actually have a separate equation, and that is for future lessons along the class. But today I just want to kind of give you an idea of how to set up these tallies of energy and how to keep track of where the energy is coming from and whatnot. And it really kind of comes down to what your system is defined as. Thank you very much, and I'll catch you next time.